Hi, welcome everyone. I'm really thirsty, but my glass of water's still on the way. But let's get started anyway. So I'm really happy to be here in Vilnius again. Oh, you've got blankets. So I just have to keep warm by moving. I'm really happy to be here again in Vilnius. It's always great to come to Build Stuff. It's a fantastic conference. I'm sure you'll agree the talks have been great so far. So I hope I can live up to that as well. My name's Adam. I live in Switzerland and I work for a company called Particular Software. Has anyone heard of Particular Software? Yeah, you might have heard of Service Bus as well. Service Bus, yeah. So we are makers of Service Bus. I'm not going to talk about that too much. But at Particular Software, our company mission is to help developers and organizations to be better at building complex software systems. Now, in doing that, we talk to a lot of people. We talk to a lot of customers. We talk to a lot of kind of senior developers like yourselves that come to conferences. We run workshops, and we talk about problems they're having in complex software systems. And one of the really common themes, or one of the really common things we realize in those conversations is that if the service boundaries were different, so if you've sliced up this system in a different way, we probably wouldn't be having this conversation, i.e. the problems wouldn't actually exist. So I think it's really important to talk about finding the right service boundaries, and that's what we're going to talk about today. So let's have a look at a system. This is just a system, right? Any system. And it could be classes or methods or functions, but we tend to do this. We tend to split up our system into different components. We don't tend to write program main and then just put everything. Sorry, just trying to stop this rubbing on my beard. Is that better? Yeah. So we don't tend to write program main and then put everything in one big method, or at least I hope you don't do that. I used to do that back in the 80s when I learned programming, but we've evolved since then, and we tend to split our system into different components. And this is actually quite a nice system, right? It actually looks pretty nice. And that you can kind of see that there's a component up here where you can say, well, that part of the system probably has some kind of responsibility, and the components under here are only called by this component up here. There's another kind of area of responsibility down here, but at this time we haven't actually drawn any architectural constraints. So we haven't said like these are our service boundaries. All we've got is a bunch of classes and methods. Now, sooner or later, the business might come along and say, well, you know what, I was at the pub last night and I had a great new idea, we can make a ton of money. And you think, okay, well, I think there's a way we can do that, right? But we need some data up here that's in a class down here. And you think to yourself, well, okay, let's say these are classes. These are well encapsulated classes. Each of them has a very good refined responsibility. There's no architectural constraint saying that I can't make a call from that class to that class, right? Even though the diagram doesn't currently represent it. So you go ahead and make that call, right? And you roll it out to production, and the business is making a ton of money with a new feature, and everyone's happy. Now, sooner or later, they come along with another requirement, and they say, well, I was in the shower this morning, I had a great new idea, and we're going to make a ton of money. So you say, okay, well, we can do this, right? We need some data up here that's in a class down here. And you think back to the last time you did it a couple of weeks ago, and you say, well, that worked out pretty well, right? So let's just do it again. We're making a ton of money, let's just do it again. So you make the call, thank you, and you roll it out into production, and everyone's happy again, and again, you're making a ton of money out of a new feature. Now, the thing is, sooner or later, you'll end up doing the same thing again, and you can kind of see where this is going. So, over time, and it could be a large amount of time, it could be months, it could be a year or more, no one intends to do this. No one intends to make a mess, but you could end up with something like this. Right? It's starting to represent a plate of spaghetti. We've got lines going everywhere. And the problem is, this diagram stops being useful. Because you speak to your colleague and you say, well, you know that feature we rolled out last week, did you use the diagram? And they'll say, what, that thing? No chance. It's completely useless. So you may as well just take the lines away and just draw a bunch of boxes, right? You've just got a bunch of classes. Now, at this point, it becomes difficult to make changes because every time you want to change something, you have to kind of go on a code safari, right? You have to go spelunking through the code, trying to make changes, hoping you're not going to break anything, and kind of discovering what you need to change, the knock-on effect of something else you change as you go along the way. Does it sound familiar? I saw a few smiles when I put this slide up on the diagram. You may as well just draw a big box, right? Because you can't really think about the different classes in isolation anymore. They have little meaning because you have to change a bunch of them at the same time anyway. And this is what is often known as a big ball of mud. So we've coalesced back to this kind of thing we're trying to avoid. Has anyone else seen this kind of architectural pattern used? And unfortunately, probably most of my career I've spent dealing with systems like this. And they never start out like this. They always start out so nice and simple, but they coalesce back to this pattern so often, it's really frustrating. But we know we can do better, so that's why we split things up into services. So, service-oriented architecture, you can call it microservices, whatever you like. I like to stick to the original terms more often than not, but we split things up into different services to try and isolate functionality, to make change easier to make. And we have loose coupling between them, right? I've drawn these lines deliberately small and thin to demonstrate the fact we want loose coupling between these services. Now, sooner or later, the business will come along and say, well, I was in the gym this afternoon, and I had a great idea for a new feature. We're going to make a ton of money. And you think, okay, well, that kind of works. But what we really need is some data from this service over in this service here. Now, it might be something really innocuous like a price, right? Price of a product, 25 euro or something. How harmful can that be? It's still loose coupling, right? It's just a number. So you go ahead and you make that call. You make the call between the two services. You roll it out, and everyone's happy again. We're making a ton of money from this new feature. Sooner or later, the business come along again. And they say, well, I was, what's he doing now? I was in the shower last night. I had a great new idea for a new feature. And you think, okay, well, I can do this, but we need to get some data from this service to this service up here. Now, again, you can see where this might go. Again, no one sets out to make a mess. No one sets out to do this. But over time, and it could be a considerable length of time, you can end up going back towards this kind of thing. It looks very similar to the last diagram, right? Back to a kind of plate of spaghetti. And as you can see, we might as well take the lines away and the boxes away once it gets so complicated, and we can easily end up in the big ball of mud. Only this time it's a big ball of mud with a difference, because you've rolled out each of those 4 services onto 4 different machines. They're talking over the network. That's a lot more costly than class-to-class calls. You have to roll out probably a couple of them or 3 of them or even all 4 of them at the same time, so your distribution model is more complicated. So you've introduced a service-oriented architecture, and you've ended up in a worse place than you started with. So how can we avoid this? Well, let's have a look at an example. Let's have a look at Amazon. So Amazon is a good example of a company which operates in a very service-oriented fashion. In fact, it's one of the most service-oriented architectures in the world. It's not just like 1 terabyte Amazon.exe. They do roll out many little things. They do it all day, every day. So taking a look at an Amazon workflow, I'm sure most of you have seen something like this. Once you've selected your products, once you've filled your shopping basket, you place your order. And that starts off a workflow. So you end up with selecting a shipping address. I think I must have been at a conference in Germany at this time. Finance, putting in your credit card details, etc., 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 shipping options and so forth. And in the end, you place your order, right? Let's have a look at how that might look in the back end. So you may have 3 services, so a sales, finance, and shipping service. So when you click place your order, we send a command to sales to say place your order. Sales then does its work. It does the stuff that it knows about. Now, have we still got this item for sale? Are we still allowed to sell it? Is it in stock? If not, can we order more? If it's all good, all green, good to go, it says, all right, order's been placed. Creates a row in its database for the order and sends an event called order placed, and that gets picked up by both finance to actually bill the order. And once finance has billed the order, it raises another event, order billed. And once shipping has received the order placed event and the order billed event, it then goes and ships the order. and it raises another event order shipped for something else to do somewhere else in the workflow. Now the question is, what should each of these events contain? What data should they contain? Should order placed contain all the information that shipping needs in order to ship the product? Should it contain all the information that finance needs to bill for that product? I.e., should it contain the address and the credit card details and all the rest of it? Now, that would work, right? I think that would work. But what's the problem with that? It's coupling. So the problem is, we can no longer make a change to finance in how we bill for stuff. We can no longer make a change in shipping for how we ship stuff. You know, what happens if we want to start charging in Bitcoin? What happens if we want to start shipping ebooks to email addresses? All of a sudden, sales has to change in both of those use cases. Sales all of a sudden has to know how to put Bitcoin information on the event for finance. It needs to know how to put ebook shipping information on the event for shipping. That's a high degree of coupling between the services, and that's what we don't want. We don't want that sharing of data. That's what we saw in the previous diagrams, which led to the spaghetti and the big ball of mud. What if the order placed event only contained an ID? What if it said, the order's been placed, the order ID is 123. And then order bill said, the order's been billed, the order ID is 123. When finance receives that event, it says, order 123, I know how to charge that. I know that I need to charge this credit card, or I need to try and charge this Bitcoin wallet. Shipping says, order 123 has been placed. Order 123 is being billed for. I know exactly how to ship that. I know I need to ship it to this physical address, or I need to send this email. Now that's nice, because that's a low degree of coupling. The only thing they're sharing is an ID. But how on earth should finance already know? Because we create the order here, right? It's sales that creates the order, and it says, yes, okay, there is an order now. So if we only know the order ID when sales created the order, how can finance already know how to ship the order for order 123? How to charge for it? How can shipping know how to ship it? Well, placing your order is at the end of the workflow, right? If you go back here, that's the end. Starting the workflow is place your order. At the end of the workflow, starting the workflow was pressing this button. Then you went through this and then this and this, and then this was the end of the workflow, actually placing your order. What if we reverse that? What if we turn that upside down? What if we create the order ID at the beginning of the workflow? What if we create it here when you go proceed to checkout? And you can do this client-side too, right? There are client-side libraries for generating GUIDs or UUIDs. What that allows us to do is that when we get here, we already know the order ID, right? Because we created it before we got into the workflow, right at the beginning. When you click ship to this address, you send the command to the shipping service to say, this is the address for order 123. When you say, these are my credit card details, you send a message to the finance service to say, these are the credit card details or the Bitcoin wallet details or whatever for order 123. By the time you get all the way over to here, to the end of the workflow, that's where we come in back here at the end of the workflow. These have already received the IDs for shipping for the address and the credit card details during that workflow, right? So now you can see how that would work. Now you can see how saying the order has been placed and the order 123 would work, because shipping already received and finance already received the details for that order ID during the workflow, not at the end. We can now add Bitcoin payment, right? We can now add ebook shipping by only making changes in the shipping service or the finance service. Sales doesn't need to know. The one big trick there was creating the ID at the front instead of at the end. It allowed us to go from fat events to thin events with only IDs. So what is it? Why is it that we ended up with this? When we tried service-oriented architecture the last time, why did we end up back in the big wall of mud with this distributed ball of mud. It was the sharing of data. This is the thing that started the ball rolling down the hill, and the mud started accumulating, and we ended up with a big ball of mud at the bottom. This is what we want to avoid. So let's try and formalize this a little bit. What is a service? First of all, what a service is not. Something which is just a function, like it does calculation or validation or something like that. That's not a service, it's just a function, right? That is a classic definition of a function, of what a function is. Something that only gives you CRUD, create, read, update, delete operations on data, that's not a service, it's just a database. Doesn't matter if you've got HTTP on top of it, right? You don't just sprinkle magic HTTP dust on top of a database and say, hey, we've got services, right? Which I've seen happen a lot. All you've got is a database. You've just changed a technical entry point into it. A service is the technical authority for a specific business capability, right? Business is the operable word here, right? All data and business rules reside within that service, right? It's about encapsulation. And really importantly, nothing is left over after identifying services. You don't just sort of say, okay, well, we've got our service A, service B, and other stuff, which we can't find a home for, because it's the other stuff that drives you towards the ultimate service boundaries. It's when you've got something difficult to place, that's when you ask the most valuable questions. So you must never avoid placing something. Don't just have like a mixed bucket at the end. Something must always be in some kind of service. And after all the code we write has some kind of business meaning, right? Right? Unless you're working in a CV, right? But ultimately, we're being paid to write code for some business capability. If it has no business value, we're not writing it. So it's logical that all code belongs to business capability, and a service is the definition of that business capability from a technical point of view, so it follows that everything belongs in some kind of service. As I said, it's all about encapsulation. So if you think back to the days of procedural programming, that lasted for a while, but it kind of failed fairly early because it didn't have any strong notion of encapsulation. Object-oriented programming was always about encapsulation. Right? I don't know if you've read anything about the original papers from Alan Kay and people like that, but they never talked about polymorphism and inheritance. It was always messages coming in, internal operations on internal data, messages going out. That in a nutshell was OO. But the thing is, in an object-oriented program, you can't do much interesting unless you share some kind of data. So an object is not enough. We need something bigger. So you can look at components, right? For instance, .NET assemblies or the Java equivalent. They're better, but they don't really encapsulate all their data because you have to have some kind of data going in, data coming out. Now the thing is, they are technical boundaries, right? A class is a technical boundary. A component is a technical boundary. Services are not. Services are aligned along business boundaries. They are aligned along business rules. They are logical, not physical. And that brings us to systems versus services. And now this is a very, very important distinction to make. So these are some systems. So we have a mobile app. We've got a back-end app written in .NET, and we've got some kind of portal written in Java. Now, sometimes it's tempting to draw our service boundaries along these lines. But what's important? These are technical boundaries. These are not logical business boundaries. A service cuts across potentially all three of these things. So a service here may have components in a mobile app, a backend app, and a Java portal. But it serves some kind of logical business function. And it's so important to make this distinction, to decouple the logical from the physical. Services are logical design time concerns with business-aligned boundaries. Systems are physical runtime concerns with technically aligned boundaries. It's a many-to relationship. So you may have a component with a service with components running in many systems, a system with components from many services. It's almost like it's like a Lego board. You know, you have that green board when you play with Lego, and you can have different piles, right? Think of the green board as the basis for a system, like a front-end app, for instance, a mobile app. The piles of bricks are your services. You pick bricks from each service and you build your house or whatever it is on the green board. That's your system. And I can't say this often enough, because I think if there's one single thing I'd like you to take from this talk, it is this. It is this decoupling of the logical from the physical. This was the eureka moment for me. With this is kind of at the root somewhere, right? This is the enabler of a lot of the other good things I'm going to talk about. If you don't have this decoupling from the physical to the logical, it's a massive artificial constraint that will lead you down the road to sharing of data towards coupling between physical systems. So let's have a look at a real example. So decomposing a domain. Now, if we talk in a kind of retail environment, this is quite a common kind of thing to see. So the business might tell you, oh, well, we've got customers, we sell products to them. So the first thing you do, you get around your whiteboard and you draw some nice big boxes and you write on one of them customer and on one of them product. I say, well, what's a customer then? Well, it's got a first name and a last name and a status. It's got a name. Product's got a name, a description, and a price. Now, the interesting thing here is that we need to start looking at the details and not thinking so much about the high level, right? It's a little bit counterintuitive as to what we've been taught, but we need to start thinking about the actual details of what these things are. Now, when you do that, you need to talk to your business and ask them questions, but the thing is, the business often don't know what they want, but they more often know what they don't want, right? So you can use a technique called anti-requirements, and you can ask really dumb-sounding questions like, all right, so we've got this stuff up here, first name, last name, status. All right. Customer first name. If that begins with the letter S, does it affect their status? And at that point, the business will look at you in a strange way and they'll say, that's the most ridiculous question I've ever heard. You don't have any idea about this domain, do you? And they say, well, not only would we never do that, that is so stupid, no one in this whole industry would ever do that. Now, hold on to that, right? You've struck gold, because what have they just told you? They've told you a stable business rule. They've told you that status has nothing to do with first name or last name. So the first thing you should do then is put them into two separate piles, right? We don't want them in the same place if there's no relationship between them. And this is what we're trying to do at this stage of modeling. We're trying to make piles of things. We're trying to take all this information we've got and we're trying to put it into piles of stuff that seems to be related to each other. You might ask then, what does customer status mean? What do we use that for? And they said, oh, well, we use that to work out how much to charge them, because if they're a gold customer, we charge them a bit less, we give them a discount. And they say, okay, well, hang on, I saw price somewhere here. Oh, yeah, here. So you're saying that customer status affects the price? Well, yes, obviously it affects the price. Great, so you put it in the same pile. You don't know the exact relationship yet, but you know they're related somehow. You know there's a connection between them. So when you hear that, put them in the same pile. What have we got left over? We've got the name, the description of the product. That kind of goes hand in hand, right? Because if the name of the product is a Dulux something something, you want the description to tell you why it's Dulux and why you really need it and why you should buy it. So we're going to put them in the same pile down here as well. Now, we've ended up with a very different model here, right? And you can imagine this is a very, very simple example, but a more complex example. You'll end up with something looking entirely different from your original whiteboard drawings. It's about the field, not the entity, right? And this is hard because our eyes and our brains are kind of wired to look for physical, tangible things. We naturally reach for them. We naturally want to draw customer on the board. Because we have this notion of a customer as an actor in the business. We want to draw product on the board. It comes naturally to us, but we have to try and resist that temptation. Whenever you hear yourself saying something like, customer has a first name, watch out for that bit in the middle. Has a. Whenever you hear yourself say has a, it's very likely you're going down an entity-driven model approach, rather than a use case approach. Modeling is about behaviors and scenarios. It's not about these tangible things that we imagine exist. I even goes for... has anyone read Eric Evans' book, the Domain-Driven Design book, Blue Book? A few of you. It's quite a famous book, and it's got a lot of good stuff in it. But Eric himself has said that the first half, about entities and aggregate roots and all that stuff, first of all, he said he wished he put it second, because a lot of people read the first half of the book, get really excited, go to work and start writing entities. And then they might just forget about the second half of the book completely, or they might get to it eventually, but he wished he'd put it second. Then later he said he wished he put it in an appendix. Then later he actually said he wished that he left it out altogether. Entities can be a useful technical pattern within a code base, within the detail of the code base. As a modeling approach, it's very dangerous. It leads you down the wrong path. And that again is turning a lot of the ideas we've had up until now, a lot of the things we've been taught, and it's turning them upside down again. I appreciate that. But I'll go so far as to say entities, bad in this context. Scenarios and behaviors, good. Details, properties, use cases. Now, at this point, another really good tip I can give you is don't name these things too early. Right? Sorry, I know it's a bit difficult to see the bottom of the screen, but give them dumb names like red, green, and yellow, or names of planets or whatever. The reason for that is if you name these things early, those names, first of all, they get in the way, and they lead you down the wrong path. Because you can have conversations like, you've identified a little bit of data and you can't find a home for it, and then you think, oh well, maybe it belongs in there, and then someone will say, no, hang on, that's products. It can't possibly belong in products. Or that's pricing. It can't belong in pricing. So the name's getting in the way for no good reason. When you've analysed use cases and you've talked to your business, they've said that it's related to stuff in that box, but someone's saying, no, but that's finance, it can't belong in there. And that really does get in the way. I've seen this happen in practice. The other thing is you'll look at something and someone will immediately say, oh yeah, that belongs in billing. Yeah, that belongs in inventory. So the name leads you to put something somewhere it doesn't belong, and it can distract you from looking at the use case. So beware about naming these things early. In fact, I've worked in teams before where we've decided never to give them meaningful names. Right? It was it's especially more obvious in abstract domains. So I used to work in banking, and I don't do a lot of kind of risk analysis and trading on a personal basis, so it's unfamiliar to me. So we said, okay, we're going to leave these things called, we actually use kaiju monsters, so like Godzilla and more obscure ones like Udaku and Mothra. And we said, okay, let's just leave those names there. We know more or less what Godzilla does. To try and give it a meaningful name won't really give us much benefit, so let's just leave the meaningless names there. So naming these things can be very dangerous, if done at the wrong time or if done at all sometimes. Looking at another example, insurance. So does anyone here work in insurance? No one at all. I think that's the first time no one's... one person, thank you. So insurance is interesting because insurance is really... There are kind of two parts to insurance, right? So correct me if I get this wrong, but there's a kind of front office which is responsible for selling policies, right? These are actually going out and getting business and selling policies to customers. And ultimately, that's all about fear. In fact, I gave a version of this talk in Russia once, and they told me that the Russian word for fear, the Russian word for insurance has the word fear in it. Right? So it's really about, that's what the front office is about. It's about selling fear to make you afraid enough that you're going to buy insurance against bad things happening. The back office, on the other hand, handles the claims. So when something bad does happen, you send in the claim and the back office handles that. And ultimately, the back office, their job is to pay out as little as possible when a claim is made. Right? Now, does that sound about right? So, thumbs up. So it sounds a bit cutthroat, but that's the DNA of a successful insurance company. It's selling fear, paying out as little as possible, and it's a case of the general case of any business, right? Maximum money in, minimum money out. So very often you might see service boundaries aligned along those lines. You might see something like a policy service, which is kind of front office oriented, which is about selling policies and drawing up details of policies, and you might see a claims service, which is kind of back office oriented. All about handling claims. Now, I have insurance, right? But I don't know much about the insurance business. But the thing is, I can look at that and I can say almost straight away, those service boundaries are wrong. Now, why is that? Let's have a look at the use case. You crash your car. You send in a claim to get your car fixed. What's the first thing the claim service is going to do? Remember that their job is to pay out as little as possible. They're going to read the fine print, right? They're going to read the small print. They're going to find out what we can do to get away with not paying this. Right? That is their first objective. Now, that means they need to know about the policy. Right? So they're going to do a whole load of request response between there's a whole load of data that's going to go across the wire between the claim service and the policy service, so that claims can do its job. And it doesn't matter that, okay, they may have published it earlier, right? This may have already been holding a cache of all these policies. Doesn't matter when it goes across the wire. It's the same data coupling. This has to know a lot about the internals of this. You may as well just take the boxes away, right? You've just got a big thing. Right? Don't want to say ball of mud necessarily. It might be well written. But you've just got one big thing. You don't really have a service-oriented architecture. Now, it's all very good saying that the boundaries are wrong, but what are the right boundaries? Well, the thing is, it can be very difficult to find this out, and especially if you're in a kind of consulting role. So if you've been brought in as a consultant to find the right service boundaries, days might go past, right? And you're getting no closer to find the right boundaries. And then after 4 days, the business say to you, have you found them yet? And you go, no. But I'm getting there. But eventually, after talking to the business and examining enough use cases and looking at the details of the data, you suddenly you have a flash of insight, and you realize that, well, you know what? All the use cases I've heard, I've never seen anything cross over from car insurance to travel insurance, right? Because you have a car accident, you don't show them your sofa, right? Or your sofa burns down, you don't show them your lost luggage receipt. There's nothing going on between these different types of services. So you draw out that on those kind of lines. So we have home insurance, travel insurance, and car insurance. And it seems to make sense. When you look at the use cases, you realize that there's no kind of request response going between them really. They're kind of self-contained. Now, you get excited about this and you say, right, I'm gonna tell the business about this. They're gonna love me. They're gonna feel like they've really got their money's worth here. So you get them into a room and you say, right, earth-shattering news. Guess what? I've found out something which is going to change everything. Home insurance is different to travel insurance. And the business are going to look at you and go, so hang on a minute, how much have we paid you to tell me something I've known for my entire career? Right, the entire industry knows that car insurance is different to travel insurance, is different to home insurance. Now, again, hold on to that. You've struck gold. If the business say to you, but that's obvious, it's a strong indication you've got things right. Kind of makes sense, right? So you might ask, well, why didn't we just ask them in the first place? Why did we just spend a week talking to domain experts and going through use cases and trawling through properties on fields and all this kind of stuff? Why don't we just ask them in the first place? How's your business organized? Well, the thing is, that's obvious, but so is that. When you might get lucky, right? You might go to your business and you might say, how's your business organized? And they say, oh, well, we've got car insurance, travel insurance, and home insurance. Great, those are service boundaries, off you go. Or they might say, we've got a front office and a back office. Or they might say something else. So there's a lot of obvious ways about having a conversation about how a business works. But the problem is the top-down approach won't necessarily lead you in the right way. As I said, you might get lucky in all the use cases, in all the possible ways of cutting it up. They might tell you something like this, which happens to be right, but the probability is incredibly low. Top-down modeling is not the way to do it. I hope that's becoming apparent now. It's bottom up. It's looking at the use cases. the devil really is in the detail. That phrase is so relevant to this. The devil is in the details. There is no getting away from looking at the use cases. And we're reluctant to do that. We like to go to the whiteboard and start drawing boxes. Right? We love doing that. We love the entity first approach. We say, okay, well, let's not get involved with the detail right now. We don't have time for that. That'll take ages. Let's start with a high level. Let's start drawing the boxes. Then let's start writing some code. We'll get into the detail later. I hope I've demonstrated to you why that doesn't work, why that will lead you down the wrong service boundaries, why that will lead you down to the highly coupled system, which doesn't have any true boundaries. It's the analysis. Don't shy away from the detail. You have to spend the time looking at the use cases. Bottom-up approach will lead you to the right boundaries. Top-down, very dangerous. And this is an example of an organizational boundary. So organizations are interesting. It's sometimes very tempting to say, okay, we've got a marketing department, we've got a finance department, we've got a sales department. Okay, great. Those are our boundaries, right? Let's go. Those are our service boundaries. But the problem is that may have worked at one time, right? So if you take yourself back to the days before computing, really, before businesses got automated with the computers. So in the old days, we had filing cabinets, right? So businesses were really organized with, you had to have your data next to you because data access was very expensive. You actually had to go and get a physical file, right? So if you had to get files from all around the building, one from over there, one from over there, one from across the road, one from the other building, that's a very expensive way of doing your job. So companies were forced to organize departments with their data, right? Companies were almost forced to be service-oriented. And you kind of go to your filing cabinet, pull some stuff out, you look at some stuff, you put something in your outbox, a trolley person will come along and kind of take it to the next person, put it in their inbox. They go to their data, which is next to them, look through something, tick some boxes, put something in their outbox, go to the next person. So those days, if you came in, you wanted to automate that company, it might have been a good shortcut. But the problem is, we came along with our fancy databases and our fancy workstations on everyone's desk, and we took away that cost of data access. Right? We made data access very, very cheap. As long as you've got the right permissions, anyone, anywhere in the company can access anything. So departments transformed into something else. They transformed into some kind of mini kingdom or fiefdom, where managers really use the departmental structure as a way to elevate themselves on the org chart. The more people you've got working for you, the more important you are, the more you're likely to get bonuses and raises. And I don't know if you've seen this phenomenon, but a manager leaves, and the other managers in the surrounding departments pick over the bones, right? And they say, oh, I'll have a bit of that, I'll have a bit of that, and I'll have a bit of that. That results in two things. First of all, it changes often. I've worked in companies before where my organizational code has changed 8 times in a year, right? So it changes very often. It's not a stable thing at all. And it doesn't represent the business boundaries. If you model your services around that, not only are you going to have to change them wildly all the time, you're going to be modeling, I don't know, maybe a manager's skill enterprise building, empire building, rather than the business itself. So beware the organizational boundary, and it's a real shame because it would be a really nice shortcut. But in the modern organization, the modern department, it really is a very dangerous thing to look at. Right, I'm going to say a few words about microservices. I mentioned them earlier. So, a lot of good things have come out of microservices, but I do have one big concern. So let's have a look at the ball of mud again. This is the thing that we're trying to avoid, right? So we read about microservices and say, okay, well, this is one of the tools we can use in our fight against the big ball of mud. So we split this up into 5 microservices, and things seem to be going well. We've definitely got a nicer bit of code organization here. But then we read some more literature, and it says, well, typically organizations have 10, 20 microservices running, and so we've only got 5. It's not really enough, right? We need a few more. Right? So split it up into 13, I think that is. So you've got 13 microservices. Okay, we must be doing microservices now, right? Then you read some more literature, and it says, well, you shouldn't have a microservice which takes longer than a week to rewrite, or something. Or even worse, shouldn't be X lines of code long, or something like that. So you split it up even more, and then you end up with a much bigger set of microservices. Look familiar? And sooner or later, the business come along and say, well, we've got this new idea. When I was driving to work this morning or whatever, and it's like, okay, well, we can do that. We can make a call from here to here. There's no architectural constraint saying we cannot do that, right? Each microservice is nicely encapsulated as a nice defined interface, clear inputs and outputs. It's exactly what it's designed for. So you make the call. Then the business come along again. I'm running out of ideas now, but they were at a football match and they had a really good idea, and say, okay, we know we can do that. We make a call from here to here. You know exactly where this is going, right? It's exactly the same diagram as before. Over time, and again, no one intends to do it, but over time, given enough time, we can end up in a situation like this. We've already seen that we can take the arrows away, we can take the boxes away, and we've ended up back in the big ball of mud. This time it's even worse because we've rolled this out to 100 different Docker containers. They're all talking to each other across the network. Our distribution models become really complicated, so we reach for crazy things, and we're using Kubernetes and we're using all kinds of different things to roll these things out, and that's all really cool. It's great for the resume and the CV. But we've ended up in a pretty bad situation. We've ended up with kind of big ball of mud microservices edition, right? Again, we've ended up in a we've reached for microservices, we've implemented them, we've ended up in a much worse situation than we started with. Right? It's backfired on us. So how can we avoid this? Well, we want to get back to this. We want to get back to loosely coupled services along business boundaries. Now within those, and we only want IDs passing between them, as we've seen. Now within those, we can have different components. But remember the separation of logical from physical. We've got our Lego board. We pick bricks from different piles, we put them on the Lego board, and we build a system. There's our iPhone app. Now, you could argue that, well, within one of these services, especially if we look at this one down here with a lot of boxes in it, could we not build a mini ball of mud within a service? Now, I'm not going to say you couldn't, right? You can make a complete mess with any kind of architectural pattern if you're determined enough, right? But what I will say, it's much less likely because these are already segregated into some logical business capability, and we split these things up internally for different reasons. We split them up, A, to be moved into different apps, right, to be actually picked out into some kind of system, and we might split them up for other reasons. So if we look at this one down here, this one might be something to do with bank accounts. Two of its responsibilities are to do with bank accounts, to do with the logical business capability of holding a bank account, to generate statements, and to do to lock down accounts for fraud, right? So if you see some bad activity going on, you want to lock the account until you find out what's going on, stop with withdrawals. Now, if you've got 1 million messages in the queue to create bank statements, do you want to wait for all those 1 million bank statements to have been made, to have been sent out, before locking an account for fraud? Right? The clear answer is no, because the SLAs on those two different things are very different. It doesn't matter whether bank statements are sent out this afternoon or this evening or even tomorrow. It really doesn't matter. But locking an account for fraud, you want that done within seconds, right? Within milliseconds if you can. You want it done ASAP. The business will say, we want it locked now. So you create a component for statements and you create a component for fraud. Statements you might roll out to, 2 VMs just for a bit of failover and high availability. Fraud, you might do some crazy wacky stuff with, elastically scaling containers and having 100 instances spin up when there's a load of fraudulent transactions happening and, all competing off the same queue and processing and taking queues off that within milliseconds. Now, think about the stuff you've read about microservices. Does that sound familiar? right? That's the kind of stuff that microservice literature sells. It says, well, once you've got these independently deployable components, you can scale them in completely different ways. You can have different deployment strategies for different components. So if you want to call these things down here microservices, go ahead. But these are physical concerns, right? These are physical processes that are running, scaled out in different ways. This is a logical concern. And my big concern with microservices is they distract us. They distract us from thinking about the physical, from thinking about the logical as opposed to the physical. Sorry. Because most of the literature that you read concentrates on that physical aspect. Small, independent processes deployed independently, scaled independently, and those kind of aspects. And they don't think about the logical aspect of the business capability. It's really important. I don't like the word microservices. Right? First, micro, it implies that size is important, and it is not. Service, it overloads the term service again. And that distracts us even more. Because, service-oriented architecture, yeah, we're doing microservices. It's another overloading of that term. Right? Service is one of the most overloaded terms in computing, I think. But for me, a service is a logical business concern. I prefer to call these things something like autonomous components rather than microservices. If you want to call them microservices, go ahead. One thing to notice here is that here, the physical and logical boundary happens to align. But it's only by coincidence. It's just because it happens to make sense for this logical boundary only to have one physical component. But it's not by architectural constraint, which is what microservices often implies. It often implies the architectural constraint is to have a service per process or a service per physical component. It's just coincidence, right? So, just before I wrap up, if you want to go much further into this, I am running a 2-day workshop at the weekend with Jimmy Bogard, and we go into this in a whole load more detail. This is just scratching the surface. So, if you're interested in hearing about this in a lot more depth, do sign up. I think there's still a few places left. It's a 2-day workshop, so Saturday and Sunday. If you want to go even deeper, there's a 5-day workshop run by Udi Dahan, who's the founder of Particular Software, and he actually goes into this in immense detail. It's a 5-day in-person course. There are videos available as well, but I highly recommend the in-person course. I've been on it, and it is fantastic. So for those of you who can't see that, I think we're going to share the slides anyway, right? But it's go.particular.net/buildstuff2018 with dashes. Sorry, the screen is very badly located, but we'll share the slides after anyway. So that kind of brings me towards the end. One final word. So this, as with any other practice you hear about in computing and software development, is not a silver bullet, right? It's not the golden hammer that you hit everything with. There are times and places to use service-oriented architecture, which involve finding your service boundaries. There are times not to. The most relevant example, I think, is startups. Does anyone here work in a kind of startup type of environment? A few of you, right? So I've got a bit of bad news for you guys, and that's that you want to be very careful before starting this. You want to wait until the right. Don't dive into this straight away, because the problem with startups is that startups don't know what their businesses are. Right? You have no idea what your business is yet if you're truly in the startup phase. It took Facebook a long time to realize that they're actually a media company. Right? They put eyeballs in front of media and they sell the eyeballs for advertisers. Right? That's a media company. In their case, the eyeballs create the content themselves, so it's incredibly lucrative. But they're a media company. And the thing with a startup is that what you've got is a bunch of great ideas, a bunch of clever people, and you're kind of just making a mess and just trying to find something that's going to stick. So just write whatever code you need to prove that. You know, almost everything you're writing is a proof of concept. And the thing is, you might think, oh yeah, but surely it's going to be neater if we start to apply service-oriented architecture. The thing is, as you've seen, it's about looking at the detail. It's about there's a lot of investment that has to go into it. So you risk spending a lot of time that's going to be wasted, because the thing is, it doesn't matter whether you write it kind of in this kind of fashion or just an ad hoc kind of, whatever fashion. When you find out what your business is, you're going to have to rewrite it anyway. So be very careful about adopting this too early. Make sure you think about, have we actually found out what our business is yet? Are we still in the startup phase, or do we have something that's starting to stick? And that might be the time to think about this. So it's really important to also consider when is the right time to do this and when isn't. So I think that brings us to the end. I guess we don't actually have time for Q&A, but I'm going to be around for the rest of the conference. So just come and grab me, and also I'd love to see you at the workshop at the weekend. So I hope you enjoyed that. I hope you find it useful. I've really enjoyed talking to you, and thank you very much.